Hello, welcome to this video. Today I'll show you our lung fibrosis quantification tool for micro-CT scans of mice and their lungs. You can load this tutorial dataset here with the tutorial button here, CT and then lung fibrosis quantification, and there you see a segmented lung and the reference region here for testing, and the lung segmentation can be done, or it needs to be done, for our quantification, and I'll quickly show you how to do that. So let's delete the lung and segment it again by performing a thresholding into a temp region. Here everything below minus 300 Hounsfield units, and then we add a lung class and pick here this connected component and then delete the temp class. So now we have the lung, and we can cut off the trachea here in 3D, and we can perform a morphologic closing operation to fill the holes in the lung. So now we have a lung segmentation, and this is required for our quantification tool. And now you can select the lung here as input class and perform the quantification here, and you get a table of statistics of biomarkers. Here, for example, the total lung volume, the average intensity here in Hounsfield units, and also certain standard values. For example, here hyper-inflated volume, normo, hypo, and non-aerated volume here. But also the air volume here and the tissue volume. So if you add these two up, you will get the total lung volume. And these numbers here are based on a publication here in Scientific Reports from Laura McCotsey and a few others, also guys from the pharma company Chiesi, here Fabio Stellari. And this is the paper here, and if you look at it, there is one figure, for example, here, which shows the intensity histograms of the lungs here, and you can see here for different mouse groups, saline, mild, and severe bleomycin, you have different histograms. So it's more right-shifted for more severe lung fibrosis, because the lung gets really thick and dense. And this is reflected by these parameters here. For example, this they found quite interesting, the 70% percentile. You can read more in the paper. And what our software also does is it loads here the air and tissue maps as overlay here as two channels here, and you can change the windowing a bit for a better visualization. Here this is the air map, and this is the tissue map. So there basically now you see the blood vessels in the lung, and you can show them together like this for a nice visualization of the aerated and non-aerated regions in the lung. And here this is the reference region. If you select that as input class by right-clicking at it, for example, you can perform the quantification on that region. Here, let's have a look. Oh, we have to do it on the underlay here, and there we have certain values that are kind of expected, because the whole thing has a known volume of 1 ml here, and there's a gradient in the intensity from -1000 to 0, so the mean should be 500. Here the min is -1000, the max should be like 0, and the air volume should be exactly half of this, as well as the tissue volume. Okay, I hope this helps. Thank you and bye bye.